This is the graphics engine I made for 3D Graphics AO2. As you can see, it has multiple zombie objects which move and have textures and stuff. A player one that moves and you can control it. A camera that follows the player around, and it's got a post-processing bloom shader which you can toggle on and off. And then finally, with the 3D collision, when you get hit, it does a GUI game over element which you can then exit out of. So when the game starts, it creates an STL window and it will create multiple shader objects, which will then be used during the post-processing stage. It then creates a renderer. This is the renderer draws everything to the screen. It handles all the OpenGL like projection stuff. It can handle both projection and orthographic rendering, and it also can take in both render textures and regular textures. Then the game creates the player character and the zombies and the background. These are all basically the same. They all have a position, an angle, and speed value that they store, and they also then store their texture and their model. They will have a display function which basically combines their private texture, mesh, position, and stuff with more global stuff that's in the game. For example, the current render they're using, the current shader they're using, where the camera is, and any render textures they want to bind. Finally, they all have a move or a tick function, depending on what they are, that basically just updates their position each frame or takes inputs to update their position. Then the game creates multiple render textures. This will be explained more in post-processing segment. Then they create multiple FBOs and ABOs. These are linked to, or the FBOs are bound through VAOs, and they are mainly used to store texture coordinates and vert positions for GUI stuff, and for the rendering to store full screen quads. Now the game enters the game loop. So first it handles SQL events, passes appropriate stuff onto the player to handle movement, checks if quitting, checks if post-processing needs to be turned on and off. Then we get down to the update function. This basically goes through all the zombies. It will tell them to run their tick so they move, it will increase their speed so they get faster. It will then check for collisions between the player and the zombie. This is the game's other function. It's pretty simple. It just takes in two vec3s and it will do a sphere collision detection on them by giving both of them a radius, and then it will do a basic 3D collision check on them and return if there's been a collision or not. If there is a collision, it will tell it to exit out of the game. Then the camera is updated so it's behind the player. Then we clean the previous window. We will actually display everything, which again, as I explained before, is basically just passing the, global game values. It will then pass them through. They will then be combined with the players, for example, private stuff. So for example, its texture, its model, its position, and then that can all be passed to the render, so the render can do the appropriate renderer, yes. So it renders all of the game stuff here. We notice how we're rendering it to RT, which is the render texture. This is so we can do post-processing if we choose to. The way post-processing works is basically these render textures are basically making a texture out of everything that is currently displayed on the screen, and then it is passing it to another shader, which is doing the same, taking the render texture in, making another render texture out of that by passing through another shader. It does all of this, multiple blur shaders and whatnot, before the final merge shader will merge the original render texture and the final post-processed render texture, and it will merge it into a single one, and then that can be displayed as normal. If it's turned off, it will just display as normal and skip all of this. Then we'll turn off everything we did for the rendering, so disable backface culling and whatnot. Then we will actually display the screen. Then we do a small delay just to cap the frame rate. Finally, there is this preload stuff. This is just something for the zombies, so they start off really far away because obviously there's a bit of a load at the start of the game. So basically the player doesn't die before they're loaded, so it will spawn them really far away, and then when everything's loaded, it will then move them to their starting positions for the game to actually start. It's just kind of lazy loading. Finally, there is a smaller little game loop after the main game loop. This literally just handles the game over screen, and it will just display that until they exit out of this, and then that's the whole project. I think the strengths of my project are its efficiency, because after the initial load, everything is already loaded, so the game runs really quickly and doesn't suffer with any frame rate issues, despite how many high the objects are being drawn on the screen. I think its main weakness, the lack of shaders it has, because even though it has the capacity to do more post-processing, because I only have the 5 shaders in the project, it can't do any more than bloom.